Hi guys, last time we worked on right triangle trigonometry, right triangle trig. Today we're going to do some applications of that or some angle of elevation and depression problems. Okay, here's angle of elevation and depression. The key thing once you get out of these two words, these kind of problems are it's all based on the horizontal. Look in both pictures. There's a horizontal, there's the word horizontal. It's based on that horizontal line no matter what. Angle of elevation is the angle above the horizontal. Angle depression, angle right below the horizontal, but it's all based on the horizontal. Nice looking people in green shirts there, by the way. All right, let's try one here. It says a giant redwood tree. This is one of, be honest, this is a huge use of this because it's hard to measure heights of trees. Okay, so a giant redwood tree casts a shadow of 532 feet long. So the shadow is 532. You see that down on the ground. Find the height of the tree if the angle of elevation to the sun is 25.7. Now, in this case, the ground is the horizontal. There's your angle of elevation. So I know this side, which is adjacent to the 25.7. I'm looking for the opposite side. So I'm thinking opposite, adjacent, opposite. That's tangent, right? So I'm doing tangent of the angle, 25.7 degrees, equals opposite over adjacent. All I'm going to do is I'm going to take my calculator and punch in 532 times tangent 25.7. Make sure your calculator's in degree mode. I'm getting 256.03, and that is in feet because the shadow's in feet. So 256 feet tall is that tree. That's quite a tree, like the one outside my classroom. All right, the angle of elevation to the top of the Empire State Building is found to be 20 degrees from the ground at a distance of 1.5 miles. That's a long way from the base of the building. Okay, so they measured the angle of the sun from there. There's the Empire State Building, can't you tell? And angle of elevation from the ground, there's the ground. Angle of elevation to the top is 20 degrees. This is quite not as good as the last picture. And it's 1.5 miles away, which is quite a ways. He wants to know what the height is. And we're not going to measure the height of the Empire State Building in miles. That's ridiculous. So there's 5,280 feet in a mile, 5,280. So in 1.5, you do 1.5 times 5,280. I'm going to go ahead and convert this. That's 7,920 feet away. Okay, 7,920 feet away. So let's just forget the miles. We're not going to measure the height in miles. So again, there's my angle. The height is the opposite. That's the adjacent. That's tangent again. Tangent of 20 degrees is the height of the building over the adjacent side. So I'm just going to punch in 7,920 times tangent 20 degrees. And I just hit sign on my calculator. Sorry about that. Times tangent 20. There we go. And I'm getting this number for the height. I'm getting 2,882.6 feet for the height. Again, that's a tall building. Even though we're not doing it in miles, you know, that's half a mile tall. That's pretty tall. Last slide, last problem. From a point on the ground 500 feet from the base of a building, an observer finds that the angle of elevation to the top of the building is 24 degrees. You can see that first broken line, this one right here. That's the top of the building. And that the angle of elevation to the top of the flagpole on top of the building is 27. So if you go all the way to the top of the flagpole, it's 27. So it says find the height of the building and the length of the flagpole. So it's basically asking for H, the height of the building, and K, well, you'll get that in a second. Let's find the height of the building first. Again, same deal, it's tangent again. So I'm going tangent 24 degrees equals the opposite side, which is the height of the building, over the adjacent side, which is 500. So I'm punching in 500 times tangent 24 degrees, and I'm getting the height of the building is 222.6 feet. That's the height of the building, so that's the first answer. Then it wants the length of the flagpole. So what I'm going to do first, I'm going to find the height all the way up to the flagpole. So let's find that K first. So that angle to the top of the flagpole is 27 degrees. I'm going to use K like the picture says over 500. I'm going to punch that in. 500 times tangent 27. We've had tangent every time today. That's 254.8 feet to the top of the, that's not the answer. That's from the ground to the top of the flagpole. So if this is the height to the top of the flagpole, and this is the type to the height of the top of the building, easy for me to say, all I'm going to do is I'm going to subtract out the height to the top of the flagpole to the height to the top of the building, and what that's going to leave me with is how tall the flagpole is. Hope that makes sense to you right there. Subtracting those right now, I'm getting 32.2 feet. So the flagpole, the length of it is 32.2 feet based on how big the building was and how big from the ground to the top of the flagpole was. which is pretty accurate. Okay, so hope that wasn't too bad. Angle elevation, angle depression. We'll do a few more triangles tomorrow and throw in some of these also. So still more right triangle trig. Can't wait to see you tomorrow. We'll work on it. See you, bye.